Good morning, class. Today we'll discuss about linear momentum and impulse. Before we starting, I would remind you, you guys have to know two things. One is vector and scalar quantity. In our previous chapter, we did discuss about this. And next one is Newton's second law of motion. So vector is physical quantity which has magnitude and direction, and a scalar has only magnitude. So we discussed in previous chapter. The next one is Newton's second law of motion. F is equal to ma, where force F is force, m is mass, and an acceleration. Acceleration of an object, moving object, is directly proportional to force applied and inversely proportional to the mass, which is we already discussed. So, if an object having mass m is moving with velocity v, then its momentum is defined by P is equal to m times v. Product of mass and velocity. Here P is momentum, m is mass of this moving object with velocity v. Now v is vector quantity, which is denoted by arrowhead on the top. So momentum is also vector quantity. Product of scalar and vector is vector quantity. Mass is scalar quantity. So mass is measured in kg, velocity is measured in meter per second. So unit of P, unit of momentum is kg meter per second in SI system of unit. Okay? And it is vector quantity. And its direction is same as the direction of velocity. So the direction of velocity determines direction of momentum. Now can you guys tell me what is the momentum of a stationary object? If a body is at rest, its velocity is 0. So product of mass and velocity, so its momentum is also 0. So any moving object has non-zero momentum, but stationary object, rest object has 0 momentum. So to go further into some, to understand more about this momentum, let's do two examples and to calculate its momentum. So let's start. One is soccer ball, which has especially mass, specifically about mass is about 400 gram, so which is 0.4 kg. Yes, and it's moving with velocity in free kick, that's roughly about 50 meter per second. So if you calculate its momentum, P is equal to m times v, that is of mass is 0.4 times momentum is 50, that is 20 kg meter per second. Yes. Now same way, let's calculate momentum of moving car. Okay, let's take one Honda Civic car. Yes, and its mass is about 1200 kg, and it is moving in near city 30 km per hour, which if you convert in meter per second, you'll get roughly 10 meter per second. Okay. So its velocity is 5 times less than in my example. I took this velocity of this car is 5 times less than the velocity of ball. Then if you calculate momentum, which is m times v, that is 1200 kg times 10 meter per second, you will get 12,000 kg meter per second. Yes. So in this case, the car is moving slower than the soccer ball, but its momentum is way higher than momentum of ball. Now momentum is actually measures how difficult to stop it. So I'll give one example. So in this case, the car has to be more difficult to stop than the ball. But I'll discuss again how do you physically interpret, and how do you get quantitatively we can evaluate. So this also used in sports, because you will hear sometime it is very difficult to stop some teams if they do have momentum. So they do have they are gaining momentum. It is very difficult to stop them. Okay? So before going that point, let's define this impulse. So impulse is denoted by I, which is product of force and time. Delta t, I am using this delta t, which is difference of time time during which force is applied. That means final time minus initial time. Yes. Now, if you go back and look at this F is equal to ma. So n, acceleration is rate of change of velocity, delta v divided by delta t. So if you rearrange the equation, you will get F times delta t is equal to n times delta v. So instead of F times delta t, I can write m times delta v. So I'll put over there m times delta v. So delta v is difference of velocity. So that is final velocity minus initial velocity. Yes, that is mvf minus mvi. So in this case, this mvf is final velocity. Vf is final velocity, so mass times final velocity is final momentum. So Pf minus mvi is initial momentum Pi. So Pf minus Pi, final momentum minus initial momentum is delta V. So I can also define this impulse is change in momentum. So to change momentum, we have to apply force. Okay. Now go back and look at these two examples again and calculate force to stop these two moving objects in 5 seconds. So so delta t is 5 seconds. I have to stop these two objects which are moving with velocity of 50 meters per second soccer ball and 10 meters per second this car. I have to stop it. So calculate this force to stop it. So I do have formula I is equal to delta p, change in momentum, which is mvf minus mvi from this equation. I can take it. So calculate this for this soccer ball, which is mass is 0.4 kg. Finally, I have to stop it. So final velocity is 0 minus mass is again 0.4 and initial velocity is 50 meters per second, which is moving. So that is 0 minus 20. That is negative 20 kg meter per second, which is change in momentum. So if I use these equations and calculate force, that is I is equal to F times delta T. That is F is equal to I divided by delta T. Yes, that is I calculated negative 20 and divided by, I have to stop it in 5 seconds. Yes. So that is negative 4 Newton. So to stop this ball, I need 4 Newton force. So negative sign here indicates the force is applied opposite to the direction of motion. So again, calculate the force required to stop this car. So I do have impulse is equal to change in momentum mvf minus mvi. So car has to stop. So final moment velocity is 0. So its mass is 1200 kg times final velocity 0. So 1200 mass times initial velocity is moving with 10 meters per second, which is 0 minus 12,000. Yes. So that is negative 12,000 kg meter per second, which is change in momentum. So if I calculate force, which is impulse divided by time during which force is applied, so that is negative 12,000 divided by 5, that is 2400 Newton. So in this case, I have to apply 2400 Newton force to stop this car. So if you look at for ball, I need just 4 Newton force to stop it, but this car, which is moving slower than this soccer ball, I need 2400 Newton force, which is way more than this. So it means the higher the momentum, we need more force to stop it. So I already told you, yes. Now, again, more examples. So if you rearrange this equation, so you will get F is equal to I divided by delta T. Yes, delta T. So delta T is time during which the force is applied. So if you increase the time, you will get less force. So that is we can use in different applications. So first one is while catching the ball, cricket ball, you will lower your hand. Yes. So by lowering your hand, you will increase your time of impact. So if delta T is higher, the change in momentum is same, the impulse is same, so you will get less force because this is in denominator. So you will get less halt. So while catching the ball, you will lower your hand. So increase your time of gravity. If you stationary stop it, you will get your delta T is less, so you will get more force. So that means you will get more halt. Same thing also in car accident. So they will use airbag. So airbag is spongy, so it will increase time of impact. Yes, time of impact. So it is delta T is high, so you'll get less force. So you'll get less halt. So you may survive while car accident because of this airbag. So I do have more examples over here to share with you, and I do have some numerical problem also. I will give you guys the sheets, and I'll you guys discuss in groups. I already assigned, so and I'll also help you if you guys have any problem.